Welcome back to our video series about the science, philosophy, and metaphysics behind information field technology. This is Chapter 3. It is about the main pillar of the information field concept, which looks at the concepts of David Bohm's implicate order and his work on the hidden variables. There are two major concepts elaborated by David Bohm. The first one is his work on hidden variables, and the second one is about implicate order. He also combined both concepts in one of his books. In orthodox quantum theory, there are models of particles and waves as two complementary images of reality. But these two images contradict each other. You can either describe matter as a particle, in which case it cannot be a wave, or you can describe it a wave, in which case it cannot be a particle. The question of whether it appears as a particle or as a wave depends on your perspective. If you want to locate an electron using a detector, you will find it at a certain point in space, but if you look for its interference patterns, it will behave like a wave. So, who decides if the electron is a particle or a wave? You, the experimenter. That's who. Professor Hans Primus of the ETH, Swiss Federal Institute of Technology in Zurich, said it's the free will of the experimenter deciding if the electron appears as a particle or a wave. This is where consciousness comes into play. When you measure the position of x1 of a particle p1 at a time t1, you may find it, for example, here in the middle. At this moment, the wave function describing the electron before the measurement collapses completely. A short time after t1, the time of measurement, there is no more particle. It develops as a wave until you measure again, and the wave function again collapses into one position. Meaning, when you're not looking, it behaves like a wave. If you look for it, it behaves like a particle. You can't immediately measure again, so it propagates as a wave until you look again. This is quite interesting, as the wave function before the measurement is distributed across the whole universe. If you're looking behind the Andromeda galaxy, 2 million light-years away, you'll find a probability which is greater than 0 that the electron might be located there. This means an electron is always spread over the whole universe when you look at it as a wave. But in the moment of measurement, this monster of a wave function spread over the whole universe suddenly collapses and becomes 0 everywhere. Einstein called this insane. This couldn't be possible because matter can only propagate at the speed of light. Einstein therefore named this spooky action at a distance, and he didn't like the concept at all. In fact, nobody liked it. But in 1935, the physicists of the world came together in Copenhagen, including Einstein, Heisenberg, and Niels Bohr. Niels Bohr convinced the physics community that this was in fact the correct interpretation. Einstein still didn't like it. In 1952, David Bohm published a paper in which he described an alternative version which works just as well. There is a particle and there is a wave, as you can see in the second image. The wave function and the particle exist simultaneously. Within the particle, there exists an energy called Q for quantum potential, which is derived from the wave function and directs the path of the particle through the world. This is called a trajectory. So in this theory, the hidden background is a wave, guiding a pilot wave represented by the quantum potential Q1, the particle, through reality. At each point in time, t, there is a hidden wave and a particle, but in this theory, the particle now possesses an internal energy, the quantum potential, which tells it where to go. If you're not looking, you don't know where the particle is, but it still has a position. In the Copenhagen interpretation of Niels Bohr, it does not have a position. It's a wave, which is everywhere. Both interpretations of quantum physics lead to predictions for experiments. Therefore, Heisenberg said, same results and predictions, so it has no additional value. But it does have additional value. After the Copenhagen interpretation was generally accepted, everyone said physics is nothing. It does not exist anymore. If you don't look, there is no particle, and if you're looking, there is no wave. So there is neither particle nor wave. Therefore, physics doesn't describe physics. Physics only describes our knowledge about physics. But there is no description of physical reality itself. Nothing is real. Therefore, some said that the only thing real is consciousness. The observer is the only real thing, and everything is in the mind of the observer. But David Bohm claimed that physics is indeed real, and if you take, for example, a table, the table is there even if nobody is looking at it. It consists of particles, and these are real. So in theory, within the particle, there is an inner energy representing the influence of the whole on this particle. One could take David Bohm's principle of quantum potential as a metaphor for human beings. You are an individual part of the whole. You exist independently of the whole. You are, of course, not independent of the whole. That's obviously not possible, but you carry the concept of independence within you. There is an energy which is the effect of the whole on you as being part of it. The same holds true for an atom, electron, or a photon. In the Hamiltonian, you can find this quantum potential. The concept of the quantum potential allows the individual to be an individual. It allows the particle to be real, but not independent, and the whole is represented within it in the form of a small energy. This energy can be very small because it just needs to tell us the right moment when to turn left or turn right. As a human being, we can also say, "No, I don't follow the inner voice. I do my own thing." But the particle doesn't have this freedom. It will always follow. That's the difference between physics and biology. We possess free will. We have this spiritual independence of following or not following our inner voice. This inner voice doesn't conduct energy. It has small energy and is mainly information. And that's the point. It's the information field. It does not kick us towards the right direction by a strong force. It only gives us the information, for example, whether to turn left or right. So it's not about the amplitude of the energy. The effect is an effect of information. It's not a force. It's a pure quantum informational feature. So that is the information field. It's not energy. It's not a force. It cannot be measured by energy or force. But it can be measured indirectly by observing non-random behavior. This is David Bohm's great contribution to the restoration of quantum physics as a physically realistic description of reality, whereas the Copenhagen interpretation by Niels Bohr, Werner Heisenberg, and others was an idealistic interpretation, which contains our knowledge about the world. It is not an ontological or metaphysical, but rather an epistemological or cognitive interpretation. Here you see a visualization of the field that is generated in the simple double-slit experiment, where you find these guiding waves as a field of hidden variables. David Bohm stated in his essay, Meaning and Information, which appeared in the book Search for Meaning, The New Spirit in Science and Philosophy, in 1989. Yet, in a random statistical distribution of electrons with the same Schrödinger wave, we can see, as shown here, that all these particles bunch to produce a fringe-like distribution on the screen. The field of information in the Schrödinger wave is thus reflected in the statistical distribution, and in this way, we understand how the dependence of each particle in this field of information brings about the wave-like behavior of a statistical distribution of such particles. So the concept of a field of information is the implicate order, or the field of hidden variables. In the first formula, you can see how the quantum potential, which can be interpreted as a representation of the information field, is mathematically written. In the second formula, the wave function is written in polar coordinates with a real and a complex part. The quantum potential is derived from the second derivation of the real part of the radius as the second spatial derivation. The second spatial derivation is the form of the trajectory of a particle. Finnish philosopher Professor Paavo Pilkinen, who worked with David Bohm for 10 years, once said, when Bohm reflected on the mathematical form of the quantum potential Q in the late 1970s, he noticed that Q only depends on the second spatial derivative of the amplitude r, meaning on the way r changes. This means that Q depends only on the form or shape of the quantum field. This form typically reflects the form of the environment, for instance, whether one or two slits are open in a two-slit experiment. This suggests that the particle is not being pushed and pulled mechanically by the quantum field, but rather that the particle is able to respond to the form of the field, or is literally informed actively by the information contained in the field. Note that this is information for the electron, not information for us. Thus, Bohm called this type of information active information. According to this, information is information for something or for someone. It is information for an electron. For us, it is not information. It's the information field of the electron. We each have our own information field, which William Miller Jr. called the pervasive information field. If there is quantum potential, you put it into the Schrödinger equation in the last formula, which the Copenhagen interpretation does not contain, and this makes all the difference. Here you can see David Bohm together with Jiddu Krishnamurti, a very famous Indian spiritual teacher. David Bohm met with him after he turned away from the idealism behind communism. Bohm stated, "But matter has now come to signify a totality of being, ultimately of a subtlety beyond all definable limits. And thus it may equally be called mind or mind-matter or matter-mind. In this one totality, meaning provides all being and, indeed, all existence. And this is the information field, where meaning and being meet." In an interview, David Bohm expressed how he envisions the super-implicit order. "I have an idea of an implicate order, and beyond that, a super-implicate order, and so on, to orders that are more and more subtle. I say there are many more subtle levels. The word subtle has a root subtext meaning finely woven. You may think of nets of consciousness that are finer and finer, or we may think of capturing finer and finer aspects of the implicate order. This could go on indefinitely. This figure shows how the infinite sequence of the implicate order converges towards a finite limit and forms the counterpart of a transcendental pole, which may be called self-consciousness.